Dear students, now we are going to discuss about how to convert BCD number into hexadecimal number using 8051 microcontroller. Okay, so for that the first instruction is move dptr comma 4300, that we are initializing 4300 with the help of data pointer. Here we are going to give input. In this location we are going to give input, and then at dptr represents this address. Okay, so let us consider 4300, we are giving data 15. Okay, so I have considered data 15 at location 4300 BCD data. So now that 15 is moved to accumulator. Okay, that 15 is moved to accumulator. So then accumulator contains 15. Okay, so then we are moving, we are copying that data in R5 also. Okay, so now R5 register also contains 15. Okay, so then we are ANL means add immediate data with accumulator data. Okay, so F0 will be ANDed with accumulator data. Accumulator data is 15. So 15 is ANDed with F0 means we will get. Okay, so this digit will get 0 and we will get this digit alone. Okay, so 1 0 we will get. If we are adding 15 and F0 means we will get 1 0. Okay, so then we are swapping accumulator data. Okay, so that means accumulator contains 10 after adding accumulated data and F0. Now accumulator contains 10, then we are swapping. Swapping means this digit will comes here and this digit will comes here. Okay, so now accumulator contains 0 1. Swapping means lower nibble will be faster nibble, higher nibble, and higher nibble will be lower nibble. Okay, so then now accumulator contains after swapping 0 1. So by adding F0 with accumulator data, that is input BCD data, we are getting this digit alone. Okay, so this digit alone separated by adding F0 with given input data, and then swapping we will get 0 1. This digit alone we are getting. Okay, so then move A to R1. Okay, so A contains 0 1. This will be moved to R1. Now R1 contains 0 1. Then we are moving R5 to A. Okay, R5 contains 15. That will be moved to A. So now A contains 15. Okay, so then that accumulator data is ANDed with 0F. Okay, so if this is ANDed with 0F means we will get this digit will get 0 and we will get this digit 05. Okay, so this will be available in 05 will be available in accumulator after adding 15 with 0F. Okay, so then we are moving that data to R2 register. So now R2 contains this 05. And this 05 is copied to R2 register. Then we are moving R1 to accumulator. Okay, so R1 contains 01. Now we are moving that to accumulator. Okay, so then B register, we are moving immediate data 0A to B register. Now B register contains 0A. Equivalent value in decimal is 10. Okay, so then we are multiplying A and B. A contains 01. Then we are multiplying it with 0A. So in accumulator we will get 0A. 1 is multiplied with 10 means its equivalent hexadecimal value will be available in accumulator, that is 0A. Okay, so then add A comma R2. Add A comma R2 means this A will be added with R2 data, that is 05. Okay, so this is R2 data, this is accumulator data, this will be added and the final result will be available in accumulator. A plus 5 means we will get 0F. Okay, so 0F, hexadecimal value is 0F, which will be available in accumulator after adding. Then we are incrementing dptr. Initially it is 4300. Okay, so now we are incrementing, so it is now 4301. Okay, so then we are moving accumulator data to this location, incremented location 4301. Accumulator contains 0F, that is moved to this location. Okay, so now 0F will be moved to 4301. Okay, so then we are SJump halt, program will get terminated. Okay, so after that program will get terminated. What we are doing is, in this program we are giving, I am giving 2-digit data. Okay, so first we are separating this digit alone and this multiplying this digit, this single digit 1 with 10 because this is in 10th position, so that we are multiplying with 10. Okay, after that we are getting its equivalent hexadecimal value, that is 0A. So then we are separating this digit alone, 5 alone. to get 5 alone, we are adding this data with 0f, then we will get 5. So then after multiplication we are adding this 5 with that result. After that we are getting equivalent hexadecimal value in accumulator that will be stored in 4301. Okay, so now I am going to enter this program in 8051 microcontroller kit. Okay, so the program was already entered in the kit. Now I am showing how the data was entered in kit. Okay, so initial procedure is in 8051 you have to go to starting address, you have to press SP space starting address, which I have chosen is 4100. So SP space 4100 and press enter. Okay, so after that we have to enter opcode. Okay, in 4100 I have entered opcode for move dptr, 4300. This instruction occupies 3 address spaces. One for its opcode, 90 is its opcode, which was already entered. If it is not available, you may enter again 90. Okay, then press enter. So then 4300 is this address, 43 is higher order address, 00 is lower order address, that will be entered. So this is already entered, so you may go next. Okay, so 00 is already entered. So next move x a comma dptr, its opcode is E0. So E0 is already entered. If it is not available, you may enter again E0, then press enter. Okay, so after entering opcode you have to press enter to enter next opcode. Okay, next move R5 comma A, its opcode is FD, which was already entered. And then opcode for ANL instruction is 54. This instruction occupies 2 address spaces, one for its opcode and another one is this data. Okay, so 54 and F0. Okay, so and then 4107 contains opcode of swap A C4, which is already entered. And then in 4108 opcode for move R1 comma A is F9 and move A comma R5 is ED. F9 is already entered and ED is already entered. In next location opcode for ANL instruction is 54 and next location this immediate data will be entered. So 54 0F. In 410C opcode for move R2 comma A is FA and in 0D move A comma R1 instruction is E9. So FA and E9. Okay, so then in move B comma 0A, this instruction occupies 3 address spaces because move B comma this instruction is not available in opcode seat. Move direct comma direct, that will be available in opcode seat. So instead of that opcode move direct comma direct, we are using 75. So wherever we are using B register we have to put F0. Okay, that's why it occupies 3 address spaces. Wherever we are using B register, here we have to put F0 and 0A, this is immediate data 0A. Okay, 75 F0 0A. Next multiply A comma B, its opcode is A4. Wherever we are using we have to enter F0. Wherever we are using B register we have to put F0 in next location. Okay, so next A4 F0 and opcode for add A comma R2 is 2A and increment dptr opcode is A3. So 2A A3. Next move x at dptr, its opcode is F0. Okay, so F0 is entered and then 4116 contains opcode for sjump halt. It occupies 2 address spaces, one for its opcode and another one is its relative address, which is FE. Okay, so 80 FE. So this is finished. Program entry is finished. After that you have to press reset button in the kit. Okay, so then you have to give input first. Input we have planned to give input at location 4300. Okay, so there I am going to give input now. For giving input SP space 4300. Okay, so where I am going to give input, here I am going to give 15. Okay, so here I am going to give 15 and we have to see the result at location 4301. Okay, after giving 15 you have to press enter and then here you clear it. Okay, since there we are going to see the result. Okay, so now I am going to execute. Okay, so before that reset and then for execution you have to press go space starting address and then go space starting address and then enter. So now it is executing. So now we can see the result at location 4301. Okay. So seeing result SP space 4301. So this contains 0F. I have given input at location 4300 is 15. Now it is the result is its equivalent hexadecimal value 0F. That's all. Okay. So this is BCD to hexadecimal conversion.